Welcome to the lesson on section 4.4, Limits at Infinity and Horizontal Asymptotes. In this lesson, you'll learn about the relationship between limits and horizontal asymptotes, and limits as x approaches positive or negative infinity. Recall from Unit 1 that x equals a forms a vertical asymptote of f if the limit of f as x approaches a goes to infinity or negative infinity from one or both sides of a. Similarly, there is a limit definition for horizontal asymptotes. It says that y equals c is a horizontal asymptote of f if the limit of f as x approaches positive or negative infinity is c. As with vertical asymptotes, this can be true on one or both sides of the graph. For example, it's possible for a graph to have a horizontal asymptote as x approaches positive infinity, but not as it approaches negative infinity, as shown in the example. In this example, we're asked to use limits to find the horizontal asymptotes of the graph of each function. Let's start by applying the rules for horizontal asymptotes that you learned in pre-calc. We'd start by comparing the degree of the numerator to the degree of the denominator. For function f, the degree of the denominator is greater. So imagine substituting extremely large values in place of x. The denominator will grow much faster, causing the value of the fraction to draw closer and closer to 0. That makes the horizontal asymptote y equals 0. For function g, the degrees are equal. In this case, the horizontal asymptote is the ratio of the leading coefficients. For this function, it would be y equals 1/3. For function h, the degree is greater in the numerator. Substituting larger and larger values for x will cause the numerator to grow faster than the denominator, causing the fraction to continue to increase in value. So there is no horizontal asymptote. Now let's look at those same problems as limits. Start by dividing every term by the highest power of x that appears in the denominator. So in function f, x squared is the highest power of x that appears in the denominator. We'll divide every term by x squared. This creates several fractions that go to 0 as x approaches infinity. And the remaining fraction simplifies to 1. The limit of f is 0 over 1, which is 0. Now let's divide all the terms of g by x to the 4th. The first fraction in the numerator simplifies to 1, and the first fraction in the denominator simplifies to 3. All the others go to 0 as x approaches infinity. The limit of g as x goes to infinity is 1/3. In h, the numerator approaches x, and the denominator approaches 1. Substituting positive infinity causes the fraction to approach positive infinity. As x approaches negative infinity, the fraction also goes to negative infinity. So this limit does not exist. This concludes the lesson on section 4.4, Limits at Infinity and Horizontal Asymptotes.